Hey guys, welcome to Mr. Nelson's chemistry class. Today we're going to go ahead and discuss how to answer the 4-1 Distinguishing Among Atoms worksheet number 1. So the first thing we have to do in this table right here is we're going to complete the table, but we have to go ahead and figure out what each one of the topics are, or the titles. In order to do the titles, then we can go ahead and fill out the numbers below. So let's go ahead and look at the first one right here, atomic number. Well, atomic number is, if I look at my periodic table, is the number of protons, 6. It happens to also equal the number of electrons if it's a neutral atom. Okay, if it's not neutral, we wouldn't call it atom anymore, we'd call it an ion. So that the atomic number is the number of protons. Okay, that leads us over here to the number of protons. We can get that from the atomic number. Now the mass number is something a little bit different. The mass number is, according to our periodic table, is pretty much the same as this atomic weight, because we have a whole number down here. Okay, so we're going to take our atomic weight, which is actually our mass number, which is the number of protons plus the number of neutrons. So in the box, like beryllium here, the mass number is 9, which means that we have 4 protons and we must have 5 neutrons. So in order to get the number of neutrons, all we have to do is subtract the smaller number from the larger number in the box, and that gives us the number of neutrons. The smaller number is the number of protons and the number of electrons. Let's go back to our box. The number of protons is the atomic number. The number of neutrons, we have to take the mass number, or the larger number in the box, and subtract the number of protons, or the smaller number in the box.
Middle school cross country is still running today, so middle school cross country.
The number of electrons is also equal to the number of protons, or the atomic number. Now our symbol, again, we would look at the atomic number. So for 9, if I go in here and I scroll and I look at 9, 9 is right here. So that would be fluorine, because that's the atomic number. So let's go back and I can put an F right in there, so capital F. So I look at the number of protons. Remember, that's equal to the atomic number, so that's going to be a 9. The number of electrons is also going to be 9. Now if I have the number of neutrons, and I can go backwards to the mass number, so I can say 10 plus 9 equals 19. And that would be my answer for that one. So let's go on to the next one. We have number of protons is 14. That means the atomic number is also 14, and the number of electrons is 14. Now if I add these two together, 14 plus 15, I'm going to get my mass number, which is going to be 29. Now all I have to do is look at my periodic table, and I see that I have atomic number 14. I go in here, go down and find atomic number 14 is right here. There's my atomic number. That's going to be silicon, or Si. So now we can go back to here and I can put capital S, lowercase I. So let's go ahead and go on to the next one. Okay, the next one is this one right here. And so we have this number right here for the number of electrons.
Your French warden's in the office. Danica, your French warden's in the office.
So the number of electrons is also equal to the atomic number. So that's going to be 22, which is also equal to the number of protons, 22. Now I'm looking for the number of neutrons. So I'm going to take 47 minus 22. So I can pull up my calculator. Okay, and we clear that, and we can say 47 minus 22, hit equals, that's going to be 25. So we put 25 right there. Now again, I'm going to look for my answer right here for the symbol. I'm going to go atomic number 22. Go back to my packet, find atomic number 22. Here it is, titanium, or Ti. So we'll go ahead and put that down, and I know that that is titanium, capital T, lowercase I. Okay, let's go on to the next one. The next one, we have 25 protons, which is the same as the atomic number, 25, and it's the same as the number of electrons, 25. In order to get the number of neutrons, we're going to go ahead and take 55 minus 25. So if I come in here and go 55 minus 25, hit equals. That answer is going to be 30. Okay, now what is the symbol? I'm going back to 25. Look at my packet, find 25. It is manganese, Mn, capital N, lowercase n. So we're going to go ahead and put that in there, capital M, lowercase n. Let's go to the next one. We have Br, and that's the only number that we have. So let's go ahead and find bromine, Br. We look at our periodic table. We scroll over this way. And if I go up just a little bit, right there's bromine. So I know that I'm going to have 35 protons, because that's my atomic number. And 80 is going to be my mass number. So let's go back here. And so I can put 35 here. My mass number is 80. My number of protons is 35, because that's the same as my atomic number. My electrons is going to be 35. And so now all I have to do is take 80 minus 35. So if we go to the calculator and I put in 80 minus 35, hit equal, I end up with 45. Now a lot of times I want to double check my answer, and I would if I was you. 80 minus 35 equals 45. There we go. So let's go back to the next one, or on to the next one. The next one, we have atomic number of 8, mass number of 16, number of protons equals the atomic number, so we're going to put in 8. And we're also going to put in the number of electrons is 8. And the number of neutrons is going to be 16 minus 8, which is 8. And then we go to the symbol. We have to find the atomic number of 8. Go to the periodic table. Right here, atomic number of 8. Okay, so we have 8. So let's go back to this, and we know that that is oxygen, capital O. Let's go on to the next one. Okay, the number of protons is 47, so we're going to put 47 right there. The mass number is these two tallied together. So I have 6 plus 4, 60 plus 40 is 100, and then so I have 7 and 1 is 8. So I'm going to put 108 in there, but let's go ahead and check the calculator. So we're going to put 47 plus 61 equals 108. That's good. So number of electrons is also equal to the number of the atomic number, or the number of protons. So we're going to put 47 right there. And so now we're going to go look at our periodic table and find out what the symbol of that has atomic number of 47. Back to our periodic table. 47 is silver, which is Ag. So we're going to go back over here and we put capital A, lowercase g, silver. On to our next one. The atomic number is 16, which means the number of protons is 16. The number of electrons is 16. And so now we're going to add these two together. So I have 16 protons and 16 neutrons. So I'm going to have 32 is my mass number. So let's go ahead and look at 16 on the periodic table. The atomic number of 16 is sulfur. Okay, so we have sulfur, so we're going to put capital S in there. So capital S. Let's go on to the last one. We have lead. So that's the only thing that we have. So we got to get the atomic number and the mass number from the periodic table. So let's find lead. Here's lead. We have 82 is the atomic number, and 207 is the mass number. So let's go back here and we can put in 87. Let me double check that, make sure it's right. No, it's 82. Good thing we go back and check those things. So 82. And I believe this was 207, but again, we'll go back and we'll double check. Here's lead, 207, and that's what we got. So we know the number of protons is going to be 82. The number of electrons is going to be 82. And now we have to calculate the number of neutrons. Again, we'll pull up our calculator. We'll put 702 minus, excuse me, 207 minus 82 equals 125. So we're going to put 125 in there. Now we have the table complete. We can go on to question number 2. So what is the difference between the mass number and the atomic number? Okay, the atomic number is the number of protons. Well, remember the mass number is the number of protons plus the number of neutrons. So again, the atomic number is the number of protons. The mass number is the number of protons plus the number of neutrons. So what is meant by the statement atoms are electrically neutral? And this is because the atom has the same number of protons and electrons. Okay, and so they have equal numbers of charges. So the atom has an equal number of positive and negative charges because remember the positive, and I can put in a plus here, the positive protons and the negative electrons. Okay, what does the atomic number of each atom represents? The number of protons. That's what the atomic number represents. It doesn't represent the number of electrons. And I want you to understand that. It happens to equal the number of electrons, but it doesn't represent them. Okay, on to number 5. Number 5, we have how many protons, neutrons, and electrons are in the following that we have. So we're going to put down P for protons, N for neutrons, and E for electrons. So we know that when we see the number here, we see that the bottom number is the atomic number, the larger number is the mass number. So we're going to go ahead and put our 32 here, which we know that we're going to have 32 over here. And now we're going to take our 73 and subtract 32 from it because that's our mass number. So let's go ahead and take 73 minus 32, hit equals, and that's going to be 41. So we're going to put a 41 right here. We'll do the same thing with the rest of them. P, N, E. So we can go ahead and put the number right there. And that looks like a 69 to me. And that means that's the same number of electrons. And then I have 169 minus 69. So that one's pretty simple. So we're going to have 100 right there. Okay. So let's go ahead and make this a little bit larger so we can see it. There we go. So we're going to do the same thing here. We're going to have protons, neutrons, electrons. Number of protons is the bottom number down there, which is a lowercase number. So we put 86 right there. It's also equal to the number of electrons, 86. So the neutrons, we're going to take 222. So let's go ahead and put that, 222. And we're going to subtract 86 from that. That's going to have 136. So this number here will be 136. Let's go on to the last one. We have protons, neutrons, electrons. Okay, so our protons is going to be 82, according to that number right there. We're going to put down 82. That also equals the number of electrons, 82. And we have to go ahead and figure out our neutrons. Remember, our neutrons are going to be our mass number, which is 208. So we're going to go in there and put 208. We're going to subtract our number of protons, 82, hit equals, that's 126. Let's go on to question number 6. Number 6, we have to, it says write shorthand notation for the following elements and determine the number of neutrons in each. So we're going to go ahead. The superscript is the mass number. So we're going to go ahead and look at our periodic table, find aluminum right here. So we have 27 as a mass number, 13 is our atomic number. So we're going to put 27 up there. Then we're going to change that to a subscript, which is going to be 13. And we go back to our normal, and then we put down a L. And the number of neutrons is going to equal the difference between those. And I can tell by looking at it, but let's go ahead and calculate it out. 27 minus 13 equals 14. So that's going to be 14 neutrons. Okay. Now these numbers normally would go on top of each other. So my question is, how did we get this number here up high, and how did we get this one low? Okay. So I'm going to go ahead and reverse that back. So in order to get the number up high, you are going to hit on you're going to hold down control, and then you're going to put down greater than. And if you want to go down, you're going to hold down control and then put less than. If you want to go back to the normal size, whichever one you hit last, you do that one again. Okay, so let's go ahead and do this again. We have platinum. So let's look at platinum. Platinum is right here, PT. So we have 195 is our mass number. 78 is our atomic number. So we're going to go ahead and put down PT. Now I'm going to go backwards on this now. And we want to do control greater than. And I thought we said 127, but let's go and check that one. Platinum, 195. There we go. Let's make sure we're right. 95. And then we're going to do control less than. That'll get us the lower number. Go back to platinum. It's 78. So we're going to put in a 78 right there. Now we got to figure out the number of neutrons. And we're going to get our calculator back out, clear it, and we're going to take our 195 minus 78 equals 117. So we have 117 neutrons. Let's go on to cobalt. Cobalt, the symbol for cobalt is CO. Now again, let's go back and see cobalt CO. It's 27 and 59. So 59 is the first one that we're going to put in there. So we're going to go ahead and get in front of this, and we're going to put control greater than 59, control less than, and go back to our periodic table. Cobalt right here, 27, and we'll put 27 in there. And we can go over here and do the number of neutrons. And again, we're going to get our calculator out, and we're going to take 59 minus 27 equals 32, and so it has 32 neutrons. Let's go ahead and do silver. Silver is Ag. Now hopefully you get to know these as well as I do. Here's silver, Ag. We know that I have 108 and 47, so we're going to start up with 108. So we're going to come over here and put control greater than 108, control less than 47. Let's double check and make sure that's 47. Silver is right here. It is 47. Okay, so now we have to go ahead and do the number of neutrons. So again, bring out the calculator, clear it. 108 minus 47 equals 61. So we end up with 61 neutrons. Okay, let's go back to gold now. Gold, I know the symbol for gold is AU. AU. And then let's go back and look at the numbers. Here's AU, here's gold. And we know that it's 197 and 79. So let's go back to this. So we know that we're going to go control greater than 197, control less than 79. Let's double check those numbers again. Always got to double check. Gold, 197, 79. Okay. And then we're going to figure out the number of neutrons. And again, the number of neutrons, get out the calculator, 197 minus 79 equals 118. So we have 118. Hey, we're all done. That was it for what was on there. So all you'd have to do at this point is go ahead and turn it in, double check all what you have, make sure that everything is correct and you know how to do it. And hey, as always, if I make a mistake, call me out on it. Hey, as always, go Mohawks. Nelson out.